my task was to develop a device which could measure the efficiency of a Fresnel lens in a steady state environment. So what that consists of is the Fresnel lens you see here, and behind that we have a device on which the beam is concentrating. If you look here really closely, you can see it going through the small aperture, and it's being concentrated onto a copper conical heat sink. And so what that does is that receives the heat, and the heat is taken away by continuous flowing water. And so essentially what it does is by employing the steady state heat equation, the time derivative form of that, we're able to measure the power that is transmitted through the lens. The whole goal of this is we want to know how much energy is actually hitting the solar cell. So we want to know what the field efficiency of the solar cell is. How we determine how much power is received by this is very simply, we employ the heat equation, and we measure the inlet temperature of the water, and then we measure the outlet temperature of the water and the corresponding mass flow rate of the water. And by knowing those three variables, you can determine how much heat is received by this device, and essentially how much energy is transmitted through the lens. So I've basically designed this, fabricated it, calibrated it, analyzed it, and now we're testing it. I really like working for Dr. Bain. He gives you the opportunity to think for yourself, the opportunity to develop your own ideas and your own ways to solve problems. So a very open-ended way to do it. He doesn't just give us an exact, this is what I want you to do and this is what you do it. He tells us in general, this is what we need to create. So we need to create a device which measures the efficiency of the lens in a steady state environment.